Determine the area of an equilateral triangle with side lengths of x units. Alright, so we have one area of the equilateral triangle, and I'm going to find it for you in 3 different ways. So one area, 3 ways. We have Heron's formula, classic 1/2 base times height, and we can even look at it as area of a regular polygon. For Heron's formula, we need to know what S stands for, and S is the semi-perimeter. If I know that this is the base of my triangle, I'm going to use B for that, then my equilateral triangle will have a perimeter of B plus B plus B. So the perimeter will be 3B. That means that my semi-perimeter will be 3B over 2, because semi is half. Now, I also just said that A equals B equals C, and I could just keep all of them B, really, to consolidate. So my area equals S times S minus A times the same times the same. What's 3 over 2B minus 1B? Well, 1B is the same as 2 over 2B, and that makes this 1/2 B. All 3 are going to be 1/2 B. 1/2 times 1/2 times 1/2 is 1/8 times another 3/2. So area equals the square root of 3B over 2 times 1 over 2B, 1 over 2B, 1 over 2B. 3, 1, 1, 1. 2 times 2 times 2 times 2. B, 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 B. So the area is the square root of B to the 4th is B squared. Square root of 16 is 4. Radical 3 stays inside. The problem did tell us the side length was x though, so I really should change this. X squared, square root 3 over 4 units squared. However, we'll have to put this in as our answer because we said no units, no spaces. So something equivalent to that statement right there. Now, anytime you determine an area, we always give an exact answer. You do not give decimals. You are rounding, so you're not being accurate. And, you know, we really can't say that enough times. I say it constantly. So definitely leave things in radical form. That is exact. Leave them as fractions whenever possible. It's more precise, especially when you have like a repeating decimal. Obviously, if it's a terminating decimal, it's really not the end of the world, but we're going to try to leave things as a nice simplified fraction like this. That's how I've done it for every example, every answer key. I never give you decimals unless for some reason the problem is a word problem and indicates a need for that. Next up, we're going to find it using the classic approach. Area equals 1/2 base. And we mentioned in the last problem, my base is x times height. But what's my height? I can't use h. I'm going to do a little bit better than that. So we're going to use this 30, 60, 90 triangle right here. If the whole base is x, that means this side right here is half of that. 1/2 x. 30, 60, 90. That means this side is x, which makes sense because my base is x and all the sides of my triangle are the same because it's equilateral. Now this is my shortest leg of my triangle, and my longer leg of my triangle which is not the hypotenuse, the longer leg, is this times rad 3. So radical 3 over 2, x, and that's my height. Now, we'll just clean that up. 1 times root 3 is root 3. 2 times 2 is 4. X times x, x squared. Same answer we saw from Heron's formula, just written in the slightly different setup. The other one had x squared root 3, still over 4, same answer. Third, we have the area of the regular polygon approach. 1/2 apothem times perimeter. If this side is x, 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 well then my perimeter is 3x. Where's the apothem? The apothem is this line right over here. Now before we continue, let's just blow up this triangle right over here on this page. Here we have the apothem, 90-degree angle. Here's 1/2 x. This is now a 30-degree angle, and this is 60. This is my smallest side. This is really, if this is A, this is A rad 3. I want to solve for A. Divide by radical 3. Dividing by radical 3 is the same as multiplying by 1 over root 3. So my apothem will equal x over 2 square root 3. But I should probably rationalize that denominator. Apothem equals x over 2 root 3 times root 3 root 3 x root 3 over, that's 3 times 2, 6. X root 3 over 6. Now, 6 and 3 reduces, and that leaves me here with a 2. 1 times x times root 3 times x. Area, x squared, root 3, 2 times 2, 4. Well, there you have it, folks. One area and done in 3 different ways.